Okay, hello everyone, and welcome to Stat 310. This is Mathematical Statistics 2, the first lecture. I'm your lecturer for this course, Garavesh Raskuti. So hope everyone had a good summer, and even in these challenging times, and managed to stay safe and reasonably sane. And so in today's lecture, this will be a pretty light and gentle start. I'll first just talk, I'll spend maybe 30 minutes or so talking about just the logistics and the course format for this online course. And then I'll kind of motivate this course a little bit and talk about, statistics versus probability, and in some sense contrasting what you would have learned in the precursor course 309 to this course 310 and what you might expect in 310, and why it's potentially a little bit different, and I would argue more useful. And I'll try to illustrate this point with an example involving voting. So the last 30 minutes or so of this lecture will focus on that. So I'll begin with the logistics, and in particular the course format. So this is an online asynchronous course. And so the way that the course will work is that there will be two video lectures. There'll be two lectures recorded per week. So typically, for a course like this, if it were an in-classroom course, there would be two 75-minute lectures per week. And so we're going to have something similar here. So there'll be two lectures that'll roughly be between 60 and 75 minutes each week. And they will be posted at the beginning of each week on the website, and it's your responsibility to consume them each week. And in particular, a lot of the details that I'll talk about in the logistics will be in the syllabus, so you should read the syllabus. I'll emphasize the key points here, but make sure you go over the syllabus. And then the other kind of key sort of component is your section, and so this will be a the live aspect of the course. So I believe that one section is an in-classroom section, and the other two sections are online. For the in-class section, just make sure you follow appropriate protocols during this pandemic. Chushian, your TA, will be pretty clear on what those are. So he'll sort of make sure that everyone's sort of safe during those sections. So the other point is the office hours. So the TA will be holding two office hours on Monday and Thursday from 1 to 2:30 p.m. and he'll be using BB Collaborate. I'll be holding an office hour from Thursday 10 to 12. That'll also be using either BB Collaborate or Zoom. And I would strongly encourage you to make an appointment even 5 minutes before the time you want to interact during those hours from 10 to 12, because it gives me time to kind of prepare and sort of make sure that I'm sort of there and ready for you. But will be available online during those 2 hours. So that, on an online course, taking advantage of your face-to-face time is really important. So those office hours are really a great opportunity for you to do that. So now, just to continue with the logistics, the next thing I want to talk about is the textbook. So the textbook will be Mathematical Statistics and Data Analysis, and this is a required textbook. It's the 3rd edition by John Rice. It's available online for free, or if you want a hard copy, it's extremely cheap, so it shouldn't be too difficult to get your hands on it. If you have any trouble with that, please contact me. And in particular, in this course, we're focusing on chapters 6 to 14. There is just a very rough weekly schedule posted on the website, which I'll talk about shortly. And so that will kind of cover the key topics and where the location of where they are in the textbook. And each lecture, after this one, I'll be talking about where I'll be referencing which section of the textbook this covers. So the lecture notes will be closely tied to the textbook, but only the lecture material will be examinable. So if you see something that is in the textbook that was not covered in the lecture notes, then it cannot be put onto a midterm or a final. So this everything's self-contained within the lecture notes. The next thing I'll talk about is assessment or grading. So there will be weekly homework. So there'll be 11 to 13 weekly homework assignments. I'll talk a bit more about those shortly. And then there'll be two midterms, midterm 1 and midterm 2, also worth 20% each, and then the final that's worth 40%. So the homework assignments will be due each week, Thursday by 5 p.m. So, that'll sort of, like, the homework assignments are a good opportunity to check to make sure that that you're following the key material in the course. The first one will be due, you can think about that as the second week of the semester. It'll be due Thursday, September 11th. And so there'll be 11 to 12 assignments total. And, because there might be the odd gap week, for Thanksgiving or for potentially maybe one other break. But only the 10 best assignments will be used for the final grade. So the reason I do this is because, it's, potentially you guys all have other commitments too. And so submitting homework every week, there may be the odd week when you can't commit as much time or, potentially can't finish. So, if you just take the 10 best, then that allows you that flexibility. But the flip side to that is that there's absolutely a zero tolerance policy on late homework. So, I'm giving you the opportunity to skip sort of 1 to 2 assignments. And the flip side to that is that, if you don't get your assignments in by Thursday, 5 p.m., then they won't be graded. And all assignments should be submitted on Canvas. So the TA Chushian will be grading those assignments. And so they'll all be, so they should all be submitted on Canvas. And let me know if you have any trouble. Let me or the TA Chushian know if you have any trouble submitting things on Canvas. I'll just talk briefly about the midterms and the final. I'll talk a lot more about them as they get closer to the dates. I just wanted you to get a sense of when the dates are for things and just a very rough guide to the format. So midterm 1 will be on Wednesday, October 14. Midterm 2 will be Wednesday, November 11th. So you still have a fair bit of time until those. The exact format of those I haven't completely decided on yet. But what seems to be the most likely scenarios is that you'll be given a set amount of time, say 2 hours to do that, about 2 hours to do that midterm, and that will be and then you'll have to submit it within that 2-3 hour window. So that'll probably be how the midterms will go, but I'll talk a lot more about that as the midterms get closer. For the final, you should just check out the date on the Learn at UW website. That will be the date of the final. And the other thing to keep in mind is that all the two midterms and the final will all be cumulative, but with a greater emphasis on the more recent topics. So, just like other math courses, and this course builds on another course, is that all material kind of builds on top of other material. And so in that sense, I reserve the right to ask questions from any topic before what was covered. But there will generally be a greater emphasis on the material that is more recent or closer to the actual midterm or final that you'll be taking. Okay, the next thing I wanted to talk about is the course website. So almost all communication will go through the course website on Canvas. Let me know if you're having any trouble accessing that, or if there's something that you're missing. So all of the video lectures, so the 2 video lectures per week, and the homework, and all other relevant material, I've already posted some material on there now. That'll all be made available on the course website. So I encourage you to check that. So in particular, the file section has all relevant files. So make sure you check that frequently. Saying that you didn't check the website sort of not going to be an excuse. So just make sure you're always aware of what's on there. I mean, you can expect a pretty regular, weekly schedule of, 2 video lectures and 1 weekly homework assignment that will be on that particular website. And if you don't see that and you're confused, please let me know. And also, forums and messages will also be made available through the website. So, if for whatever reason, I, potentially need to change some of the homework questions, if, someone finds a mistake or something, I might post that on a forum or a message. So just make sure you check that regularly And again, if you're confused about anything, please email me or the TA, so that there's no confusion. So now I'll talk a little bit about the prerequisites, and this will also kind of lead into what we'll be covering in the first couple of weeks of this course. So the two key prerequisites, I'd say there's one very key prerequisite and then another one too. So Stat 309 or the equivalent, so like Math 431, and I really believe Stat 311 may also be a prerequisite, and Stat 302. So Stat 309 is kind of is Mathematical Statistics 1, which kind of covers probability. And then Stat 302 is more a basic is more basics in the fundamentals of statistical theory and statistical methods and thinking. So I'd say knowledge of Stat 309 is really essential, and the more you know that, the more it's going to help you in this course. And if there are like gaps in your knowledge of that course, they will likely be exploited in the course. So because of that, the first 2 to 3 lectures of this course will be a quick refresher on some elements of Stat 309. So the first 3, maybe 4 lectures, there should be no new material really. And also the first 2 homework assignments will cover this material. So you should really use this opportunity as a chance to review any gaps that you might have in 309. So, in an ideal world, you should, just be like, in an ideal world, the first 2 weeks of materials should just be very simple to you because, this has already been covered, but, I understand that, potentially you've taken 309 a while ago and some of the material may be a little bit foggy to you. So that's why I'm going through this lecture, but I'm going through the material in the first couple of lectures, but it really is your responsibility to make sure that you follow that you've absorbed most of that material. And hopefully these first couple of weeks will give you a sense of where you're at in that sense, and make sure that will encourage you to fill in any gaps in your knowledge. So the next thing, and probably one of the key things to take out of today's lecture, is just navigating online material and some general tips for how to do what I believe will help you to do well in this course. So this is an online course, and this is potentially a new experience for some of you, and it is a totally new experience to me to teach an online course. I've only had experience in teaching in classroom courses, so this will be a new experience for me. So I'll be learning as I go, and so hopefully show some patience, and hopefully I'll get better as I go along. So there's some of you have maybe taken online courses before, but just like all things, even though this may not be kind of an ideal situation or what you want, if you look at it as a positive, just like all things, there are advantages and disadvantages to having an online course as opposed to an in-classroom course. So if we think about the advantages, for example, like there is more online content available, so all of the video lectures will be made available online. And one of the key things is they can be consumed at your convenience. So when you're watching a video lecture, you can, if there's a point that's unclear, you can stop and check and think about it yourself. Whereas when it's an in-classroom lecture, I mean, if you miss something, then it's kind of gone, and then you're behind, and then you don't necessarily get a chance to catch up. Whereas because you can consume the material at your own pace, this online material gives you the option to do that. So, but this is both an advantage, but also a potential challenge for online courses as opposed to in-classroom courses, because in-classroom courses kind of force you to show up to lecture at a particular time, which gives you sort of a set routine. But for online courses, self-discipline is key, because it's required to make sure that you actually do consume the online material in an appropriate way. So, this is something that's not going to be checked, and it's very easy to kind of just say, I'll do that later, or, to sort of lose track of things when it's online. And so the first piece of advice I'd give you, and this is something that I'm implementing myself in teaching an online course for the first time, is make sure you have your own process or routine for doing this. So, in my case, I'm just making sure that, for the 2 video lectures that I produce, that I really sort of just dedicate one day to just doing that, and one particular day, and making sure that I stick to that day. And that's kind of my processes and routine to make sure that I get sort of my aspect of the work done. And similarly, from your perspective, you need to, have your own routine that you stick to make sure that you're, getting things done, and also treating this kind of like, trying to treat this as much as you're consuming things in a classroom setting. And, that's part of the reason why I'm kind of writing things on an iPad just as I would on a whiteboard. You'll actually see me write things live a lot in this course, because I want it to be as close to the in-classroom experience of writing things on a whiteboard as possible. And so following on from that, and this is sort of really important to keep in mind, just some general expectations for you and tips. So the first key expectation for you is that you view the video lectures each week before Thursday. So each week there'll be a homework assignment due on Thursday. And as I mentioned earlier, both Chushian, the TA, and I have office hours on Thursday. He also has an office hour on Monday. But the general idea is that you have actually watched the video lectures before coming to those office hours. So, if you come into the office hours and say, hey, like I haven't had time to watch the video lectures, can you tell me what's on them? Like, you're likely to get a response like, we'll go and watch the video lectures, because that's sort of that is your responsibility to do that. And so that, and like the idea of the face-to-face interactions through the office hours is just that it's to fill in gaps and to reinforce key concepts that you might have missed, not to kind of re-give you the lecture, because that's something that is available in the video lecture. And the next point is probably the most important point of today's lecture, and something that you should keep in mind. And this is something I say in all courses that I teach, whether it's an in-classroom or an online course, and that is to consume the lectures actively. And so what I mean by that is it's very easy to kind of passively consume lectures, and this is true in a classroom setting or in an online virtual setting as well. And what I mean by passively taking the lectures is, you just sort of watch it and feel like you're subliminally getting what's going on. Maybe it's late in the evening and you're tired and you just kind of turn it on and say, oh yeah, I'm listening to it, therefore I'll get it. And that's not really going to be any use to you at all in terms of, doing well in the course and, taking in the key material that you need for the homeworks, midterms, and finals. So what I mean by consuming the lectures actively is that you try to replicate the in-classroom setting as much as possible and be really active about it. So take notes as you go, and that's why, as I mentioned, I'm writing notes on this iPad just as I would write notes on a whiteboard. Do all the problems yourself. I'll talk a little bit about doing problems shortly. And the other key thing is try to recreate the content of the lecture. And so, it's very easy to sort of watch a lecture and feel like you get it. But a really good test of whether you have actually understood it or not is to see if you can, 10 minutes, an hour, a day, or a few days later, can you actually sort of recreate that lecture to yourself or to someone else? And you'll be surprised that often that's very difficult to actually do. But if you can, that's a real sort of tick for the fact that you have taken in the material. And the other thing is write down questions as they come to mind. So if you're consuming the lectures actively rather than just passively watching them, you'll be thinking to yourself, I don't get that. What's going on here? Or you might say, that's interesting, but I have a further question. And so just write those questions down. You may be able to figure them out yourself, but we're more than happy to answer questions during office hours or by email. So the next key point is to just do as many problems as you can. So in particular, do all the problems and examples that I provide in the lecture notes. and then the homework assignment. So that'll be assessed, but make sure you kind of do them and really know and understand that you really know and understand those problems. And if you have extra time, do problems from the book. So there's no shortage of questions. If you kind of go through the textbook, they have lots and lots of practice questions, and so there's no shortage of questions to do. And the more you do, the better you'll get at doing that. But as I understand, you all have time constraints. So if you follow the examples in the lecture, or the problems in the lecture, and the homework problems, there shouldn't be anything that really surprises you too much in the course. And one of the things that's specific to an online course is that there's no face-to-face contact during the video lectures. So I would say use the office hours and the sections really wisely, because that is your opportunity to have face-to-face contact. And so make sure you're you take advantage of that. So while you're watching the video lectures, if you write things down and really think pointedly about how you want to use the time in the office hours in the section, then you'll get a lot more out of it. And I kind of said this, but I'll say it again more clearly. Use the office hours or section, like watching lectures is not enough. So if you watch lectures, and this is even true in classroom setting, you can sort of feel like you get what's going on, and you can watch myself or the TA do problems and say, oh yeah, I get all the steps in that. But that isn't even close to your ability to be able to solve a question in the exam. And so you need to really be able to do the problems yourself. So a good sort of thing that I encourage all students to do is that, like if you've seen me do a question in a video lecture, or if you've seen the TA Chishian do a question, just try it a day later. Don't look at the answer, and see if you can do it yourself. And that'll be a really good test of whether you've really consumed the content. Okay, so that's everything in terms of the logistics for the course. So if you have any questions, then just please contact me if there's anything that's unclear from a logistical point of view. So now I'm going to talk about what motivates this course 310 and kind of how it compares to 309, because it is sort of a follow-up course to that. And so what can you expect to be different from the course? But also we'll sort of see through this why the material from 309 is really important. So just to kind of summarize, and I think I'll also illustrate this in an example very shortly. So 309, if you recall, you started with kind of a probability model, and you can think about this also as a population model. How I tie it to the population, we'll kind of see, with our particular example. And then from that probability model, you might draw a random variable or some data from that. And so, and then you want to ask questions about that random variable of the data. So you might ask questions like, what's the expectation? What's the variance? If I draw 100 random variables from this distribution, how likely is it that my sample average is close to the population mean as they answer that question with like the central limit theorem or the law of large numbers? These are the kinds of questions that you answer in 309. So you start with a known, the key thing to take out of this is you start with a known population model, and then you say something about the random variable in the data that you draw from that. What 310 is doing, and I think it sort of paints a much more realistic picture of what happens in practice, is that the arrow actually goes in the other direction. So you can kind of think about this as like the inverse of what you do in 309. So in 310, you start with random variable or data. And this is what you typically have in statistics in practice, that someone gives you some data and they want you to tell them something interesting about it. And so what we're going to do in this course is basically try to infer what the probability or population model is. Try and infer what the probability or population model is from the data. And this allows you to answer some very useful questions, because you're trying to use some subset of data to tell you what's going on in the population setting. And so in 310, we're going to try to go from data to try to infer the probability or population model. And so this is what we'll be doing in 310. I'm going to illustrate this with an example, and it's potentially like relevant because it's an election year. We're going to talk about voting in Wisconsin, and a disclaimer straight away, like none of the numbers that I talk about here are based on any real data or any fact. I'm just sort of throwing in these numbers just to give it to try to paint a picture. Okay, so I'm going to start with So I'm going to start with a 309 type setting and questions that you should potentially be able to answer from the material in 309. And then I'll kind of flip it around and look at the kinds of questions that we're interested in 310. Okay, so just to describe the setting, so we have a setting where we assume that 55% of people in Wisconsin vote Democrat, and we're going to assume a simple setting where it's binary, and then the other 45% vote Republican. And once again, I remind you that these numbers are not based on any fact and are not true. And then you draw an independent sample of 100 from this population. So in the entire population, you just independently pick 100 people from that, and you ask them what they vote. So just to kind of go back to this setting, so in 309, we have the population model, which is saying that 55% of people vote Democrat and 45% vote Republican, and we're drawing some data from that. So the data we're drawing is 100 samples from that. Okay, and so based on this scenario where you have a known population, you draw a sample of 100 from there. We have two sort of sub questions. The first one is, what is the expected number of people who vote Democrat in the sample, and then what is the variance on this on the number of people who vote Democrat, And then what is the probability that more than 50 people in the sample vote Democrat? So what I would recommend, to be honest, is like if I were in a classroom setting, I would say I'll give you guys 5 minutes to think about this question. So what I strongly recommend for you, for those of you who are watching this this video lecture, is to stop the video lecture right now and to take 5 minutes to try to think about how they would answer that question themselves. Okay, so I'm assuming that you've all kind of taken the 5 minutes and to think about the question, because you'll get a lot more out of this, me going through the answer, if you've already thought about the question. Look, if we look at part A, which is what is the expected number of people who vote Democrat in the sample, as we typically do in 309, we want to assign some probability model to this. So when we're thinking about voting, so voting is a binary thing of like you either vote Democrat or Republican. So what kind of probability model or distribution would we put on this? And so the most natural choice that hopefully you're thinking about, and again, for those of you who this is sort of a fair way back in your brain, this is a good chance to kind of refresh yourself. The Bernoulli distribution models binary data the best, and so we're going to use the Bernoulli distribution here to say 1 means that someone votes Democrat, so 1 indicates Democrat vote, and 0 indicates a Republican vote. Okay, and so what's P going to be? So since 55% of people in the population vote Democrat, we can say that P here is 0.55. Okay, and so what we're asking is the expected number of people who vote for Democrat in the sample. So what we want to find is that if we want to calculate the okay. So I'm going to let D be the number of people who vote Democrat in sample. In sample, and so this is just going to be the sum of these binary random variables where you ask each person, do they vote Democrat or don't they? So if it's if they do vote Democrat, then you add 1, and if they vote Republican, then you add 0. And you want to find the expected value of D. So that's your question. So we're going to do this through some simple calculations, and again, these calculations would hopefully have been very familiar to you at the end of 309. And again, it's been a while since you've potentially done this, so you should use this as an opportunity to sort of go back and check anything that is potentially confusing to you. So here we're calculating the expectation. Okay, so we have an expectation of a sum of 100 random variables. So what do we do with an expectation of a sum? We can bring this expectation inside. That is, due to this linearity of expectation property. Again, these kinds of calculations are going to come up over and over again in this course. So, this is something that, you should sort of slowly become very familiar with. And so now let's think about the expectation of xi. And there's a couple of ways to arrive at this. You could either know or memorize the fact that the expectation of a Bernoulli random variable is just the probability of its success, so which is 0.55, or you can calculate this expectation using the expectation formula. But either way, this is something that you can, hopefully calculate pretty quickly. So you're adding up 0.55 100 times, and so you get 55. So, again, hopefully it's not super super difficult to see where this comes from, but we can see that the expectation of D here is 55. Now the next thing we want to calculate is the variance of D. So this is the variability. So once again, we're calculating this variance of a sum. Okay, now the key question is, can we bring this variance inside like we could the expectation? And in this case, the answer is yes. Sorry, just some technical issues. You see, yep, got it. Sorry, yeah, this will happen occasionally. I don't know what happened there. Sorry.